Hi, I'm Noah Laith, and over the last 17 years, my medical team and I have worked with 593 autistic children. And in 12 cases, after our work together, the children no longer met the criteria of ASD, which is Autism Spectrum Disorder. But it wasn't therapy alone that got them there. Stem cells, yeast, parasite, mold cleansing, fecal microbiota transplantation, and peptides were part of what we tried. So in this video, I'm going to walk you through 12 peptides for autism. 6 have been studied for autism already, and the other 6 are peptides that we believe are worth exploring. Starting with peptide number 1, if you were going to make the perfect peptide for autism on paper, you'd probably design this one, because it's called the social hormone for a reason. Your body releases this hormone during moments of human connection, such as nursing, hugging, or feeling trust. It literally rewards social connection and lowers social fear. By now, if you haven't guessed it, the peptide I'm talking about is oxytocin. In the early 2000s, scientists asked themselves what would happen if we provided oxytocin to people with autism. I mean, oxytocin already facilitates social bonding, so providing it might help improve social connection in individuals with autism. So scientists put it to the test, and they found that in small human trials, often a single dose of nasal spray reported small improvements like slightly more eye contact, slightly better emotion reading, and a bit more trust. This led to the boom of unregulated use of oxytocin. But then, in 2014, scientists did a large-scale study with 290 children over 24 weeks. They tested oxytocin against a controlled placebo and then found that the bonding hormone actually did nothing measurable. Children on oxytocin improved over those months, but so did children on the placebo, which meant that there was no meaningful advantage in the core symptoms it was supposed to target. But to be fair, that doesn't mean that oxytocin doesn't do anything for autistic kids under any circumstance. There are still open questions about whether the nasal spray reliably reaches the brain and whether a specific, I repeat, a specific subgroup with naturally low oxytocin might respond differently. Those are legitimate questions still being studied. But on the best evidence available right now, the single most theoretically useful peptide in all of autism research did not beat a placebo. Now let's move on to peptide number 2. This peptide is chemically similar to oxytocin, and it also has the same function, but scientists had a different theory about this. Peptide number 2 is called arginine vasopressin. Studies shows that autistic children with the lowest natural vasopressin levels in their spinal fluid tend to have the greatest social difficulties. And that's why a team at Stanford ran a placebo-controlled experiment. They took 30 children with autism and gave them vasopressin nasal spray and an identical placebo spray for 4 weeks. And they found that children on vasopressin improved by nearly 13 points on the validated social functioning scale, and the placebo group showed no meaningful improvement at all. This meant that this peptide could work, but just because it worked for those 30 kids doesn't mean it could work for everyone. And that's why we always need larger trials, but we don't have that yet. So now let's move on to peptide number 3, the gluten and casein peptides. And this one is based on a theory that has shaped an entire industry, and it goes back to the idea of opioid excess theory. And here's what that means. Normally, when you digest gluten and casein, that is the proteins in wheat and milk, your body breaks them all the way down into harmless pieces. But in some autistic children, that breakdown is incomplete, and what's left behind acts almost like a low-grade opioid in the brain. From gluten, it's a fragment called gluteomorphine, and from casein, that one is called BCM7. And if a child has a more permeable gut lining, sometimes called leaky gut, these leftover fragments could slip into the bloodstream, travel to the brain, and interfere with normal signaling. One study comparing 86 autistic children to 51 neurotypical children found that the autism group had higher BCM7 levels, while the enzyme that breaks down BCM7 was also present in higher amounts. It wasn't functioning correctly, which meant that if you reduced the amount of gluten and casein, you could possibly reverse autism. But when scientists put that to the test, the results were pretty inconsistent. They did a review looking at 45 years of research from 1980 to 2025 and pulled together 17 clinical studies on gluten-free, casein-free diets in autism. But they found that there was no solid evidence that these diets improve behavior overall. A few smaller studies showed mild improvement, but the most rigorous studies tended to show the least effect, which is usually a sign the effect isn't really there. So why do so many parents swear it works at our clinic? There are a few reasons. A child's behavior naturally goes through ups and downs. So starting a new diet during a rough patch often lines up with things naturally improving anyway. A strict new diet usually comes with more structure and more attention from parents, which can help on its own. And here it comes again. For some specific subgroups of children, there might be a separate food intolerance where removing the food helps an upset stomach and a child in less pain simply behaves better. Now let's move on to peptide number 4. Most of what's on this list either failed or is still an unproven theory. But this one is different. This peptide is something your body already makes. It's concentrated in your brain and muscles, and it's in the meat you eat. Peptide number 4 is called L-carnosine. L-carnosine acts as an antioxidant and appears to support the part of the brain tied to behavior, to language, social processing, and the frontal lobe. So researchers thought if you support that part of the brain of autistic individuals, maybe you'd see improvement in exactly those areas. So in 2002, they tested it properly. Scientists conducted a double-blind placebo-controlled trials with 31 autistic children over 8 weeks, and they found something that revolutionized the entire industry for the next 20 years. They found that the children taking L-carnosine showed measurable improvements, better scores on behavior, socializing, and communication, and the placebo group showed no change. So that single study showed up in reviews, in supplement marketing, parent forums, and clinical brochures. But it's important to note that a small study with only 31 children isn't enough proof. With a group that small, the positive outcomes may have nothing to do with the supplements. And the only way to find out if it works is to run a larger trial. So researchers did that. In 2021, researchers ran the same trial on 250 children in total, which is nearly 7 times the size of the original study. The team expected the same outcome, but the positive effect was gone. There was no significant difference from placebo, and that held across every single measure. The full rating scale, socializing, behavior, communication, all of it, which meant that the original 2002 result was most likely just a lucky positive that a small trial can produce. Now let's talk about peptide number 5, which is gastrin-releasing peptide. Early animal studies and small human trials hinted that this peptide might affect core autism traits. So researchers ran a larger open-label trial, giving it intravenously to 10 children with autism. And they found that 6 out of the 10 children showed improvements in irritability, social withdrawal, and hyperactivity. And the average score on a standard autism severity scale dropped by 4 points. A second smaller trial in 3 more children showed a similar pattern, but neither of those studies had been tested against a placebo group, which meant that every parent and every clinician knew exactly which child was getting the drug. And when everyone knows a child is being treated and everyone is watching hopefully for improvement, improvement tends to get reported, whether or not the drug actually caused it. To their credit, the researchers behind these trials said this themselves. They flagged that the results needed to be interpreted with caution and explicitly called for larger randomized placebo-controlled trials before anyone jumped to conclusions. But that study hasn't been done yet, so there's no way to know if this peptide actually works or not. Now let's move on to peptide number 6. This one is the most mysterious thing on this entire list because unlike everything else so far, it isn't really one peptide at all. It's called cerebrolysin, and it's actually a mixture derived from animal brain tissue, and it is broken down into small peptides and amino acids that resemble our brain's own growth factors, and is being used for decades in Russia, in China and Eastern Europe, mostly for stroke recovery and dementia, on the idea that it helps damaged brain repair themselves. And unlike oxytocin, gluten peptides, or GRPs, cerebrolysin doesn't work through digestion or hormones to get to the brain. It's designed to cross that blood-brain barrier directly and act on neurogenesis, which is the growth of new brain cells, of new neurons and synaptic plasticity, or in simple words, the brain's ability to rewire itself. And this is important because if autism involves differences in how neurons connect, a compound acting directly on that is aiming at something much closer to a root cause than a symptom. So researchers put it to the test, and they found strong evidence but in animal data. So cerebrolysin reduced social deficits, decreased repetitive behavior, and appeared to normalize the underlying synaptic pathways. And then it moved into children. And across several studies, mostly out of Russia and Eastern Europe, researchers gave cerebrolysin by injecting to autistic children and tracked their severity scores. And they found a massive change. One evaluation reported a positive response in roughly 90% of children. By now, you already know what I'm about to say, because we have seen this exact pattern twice already in this video. Almost all of this human data is open label. There was no placebo group. And there is one more thing worth knowing before you ever consider this one. Cerebrolysin isn't FDA approved in the United States. It's approved in a handful of countries like Austria, Germany, China, and Russia. But here it exists in a legal gray area, and it's derived from animal brain tissue, which comes with its own separate safety questions beyond just does it work? Now let's move on to peptide number 7. It is important to note that the peptides that I talk about after this are purely theoretical and have not been tested yet. It comes from anecdotal observation my medical team and I have made from working with autistic kids over the past 17 years. So please take this with a grain of salt. So the first peptide in that list is thymosin alpha-1. Thymosin alpha-1 is a naturally occurring peptide made by your thymus, a small gland behind your breastbone that essentially trains your immune system. And its job is to balance the immune system by supporting the right response and calming down the ones that have gone overactive. And this is relevant for autistic individuals because new studies have shown that some autistic people, but not all of them, have differences in their immune system. They show signs of chronic low-grade inflammation in the brain, elevated inflammatory signals, and, in some cases, antibodies that react against the body's own tissue. And this traces back to immune activity during pregnancy, affecting brain development. That's why I believe that thymosin alpha-1 could help regulate immune activity in autistic kids. Now let's move on to the second peptide in the theoretical list. This peptide is already very popular in the fitness space because of its healing properties. In fact, it is often paired with TB500 and called the Wolverine stack. And the peptide I'm talking about is BPC-157. It's naturally found in the stomach lining where it helps repair damage caused by the stomach acid. And the reason I think it could be worth investigating for autistic individuals comes down to 3 reasons. Reason number 1, autistic people have gut problems. Always. Studies shows autistic individuals have roughly double the rate of GI problems compared to neurotypical individuals. And to be honest, I have never seen an ASD child with no gut problems. The most common symptoms are constipation, abdominal pain, and diarrhea. Reason number 2, the gut and the brain are directly connected, which means what happens in the gut can influence the brain and behavior through the immune system, the nervous system, and the chemicals gut bacteria produce. Reason number 3, BPC-157 repairs gut tissue. In animal studies, it consistently rebuilds and protects the intestinal lining, mostly by improving blood flow to damaged tissue. But we still don't know why autistic people have more gut problems than neurotypical people. It could be that gut inflammation worsens symptoms, but it could also be that the anxiety, sensory sensitivities, and extremely selective eating that are already common in autism can cause constipation and GI distress entirely on their own. We don't know which one causes the other. or it is hard to conclude right now. Now let's move on to peptide number 3 in the theoretical group. This one targets the anxiety and stress that most autistic people have. For a lot of autistic people, some of the hardest part of daily life are in the core trait themselves. Is the sensory overwhelm, the constant low-grade stress of moving through a world that feels too loud, too bright, and too unpredictable. So a peptide that could help manage that is really groundbreaking. That peptide I'm talking about is called C-lang. So what is C-lang? It is a synthetic peptide developed in Russia, again, in the 80s, and based on a fragment of a naturally occurring immune signaling molecule called tuftsine. It's actually approved in Russia and Ukraine for generalized anxiety disorder, and it's completed phase 3 trials there. It works by influencing serotonin and dopamine and acting on GABA, the brain main calm down network. The appeal is that it might ease that fight or flight response without the heavy sedation or dependency risk that comes with something like benzodiazepine. But that research has not been done in autistic people, but it's also still not FDA approved in the United States. So now let's move on to the next peptides on the theoretical list, C-max. This peptide is actually C-lang's close cousin. It is also developed in Russia, but where C-lang targets anxiety, C-max is aimed at cognition. It is thought to influence BDNF, a protein central to learning, memory, and how the brain forms connections. But just like C-lang, it hasn't been tested on autistic people yet, and most of the research is done in Russia. Now let's move on to the 5th peptide on the theoretical list, D-hexa. This peptide was actually developed for Alzheimer's. What makes it interesting is its target, that is synaptogenesis. Synaptogenesis is the formation of new synapses, which are the connection between neurons. In lab studies, it has been incredibly effective at building new neural connections, and it worked by using a growth factor pathway to help rewire the brain, and it is reportedly 10 million times more powerful than BDNF, which is another peptide in your brain responsible for the same task. Given that autism is increasingly understood as a condition of how neurons connect to each other, a compound that directly builds synaptic connection is a provocative idea. But the hexa data is almost entirely preclinical. There are no meaningful human trials for anything, let alone autism. And it's not approved for any use. It's sold only as an unregulated research chemical. Now let's move on to the last peptide on this list. This peptide is already known for its anti-aging benefits, and I'm using it as we speak. The peptide I'm talking about is MOTS. MOTS is a mitochondrial-derived peptide. Most peptides in your body are encoded by DNA in the cell's nucleus, but this one isn't. It's encoded by your mitochondria, which carry their own small separate genome. Simply said, it regulates metabolism, improve insulin sensitivity, and it activates a master energy sensing pathways called AMPK, and is often described as an exercise mimetic because a lot of its effects resemble what physical activity does to the body. Its levels decline with age. That's why taking it in the form of supplements is so beneficial for anti-aging. Now, the reason why it's relevant for autism is that some autistic children have mitochondrial issues, and MOTS is a peptide that optimize cellular energy metabolism, so maybe it could help that specific subgroup. But there are no human autism trials of MOTS. Almost everything known about it comes from research on metabolism, type 2 diabetes, obesity, and exercise physiology, mostly in animals and early human studies in Korea. Its connection to autism is pure speculation, and like the other peptides on this theory list, it's sold only as an unregulated research chemicals with no established pediatric dosing and definitely no safety data in children whatsoever. Now look, we have covered 12 peptides so far. Most of them are still in early development and don't have enough data to prove anything. And this is because historically, autism research has been heavily underfunded. In fact, the National Institute of Health in the US has reduced funding for autism-related research by approximately 26%. That's why I built this longevity clinic. One of our main and favorite areas, my wife and I, of research in the longevity space is autism. So if your child is on the spectrum and something in this video caught your attention, please click the link in the bio and book a discovery call.